let's talk about actually doing the job. First, we have to place the apparatus and make our connections. Then we can pump the FDC. We'll save the pumping information for the next class. To stretch your lines to an FDC and a hydrant requires two operations at once. This needs to be coordinated, so you're going to need to plan the job with the personnel that you have. For my rig, I plan to stretch the FDC while my firefighter lays to the hydrant. One reason is because I have the Knox key stored next to me, and the firefighter is usually going to carry, almost always, at least for us, 5-inch plus connections, and it may be a further stretch. I feel like I can more quickly get the smaller hoses connected that are actually going to be pumping water into the system faster, and the firefighter is also used to making hydrant connections, so it's the more intuitive job for them as well. You need to know your rig. You need to know how the hose is loaded, how long the sections are. Is it a dead load or is it pre-connected? So as you approach the FDC, you also have to identify if it's a 2.5, a Siamese, a Storks, or whatever other kind of connections you may use in your district. Also, you've got to identify that hydrant. Is the hydrant on the same side of the road or the access as your FDC? If it's on the other side, you're going to be potentially blocking access or stopping a road. So if you're going to do that, you may or likely need to relay that information to the incident commander to see if he wants you to continue that FDC op right now, or possibly delay it until a unit or two can get through. Based on his strategy and needs at the time, he may pause it. He may have you go ahead and connect it. They can walk. It's just up to them. But if you get that order confirmed, go ahead and make your approach. Place your apparatus. When placing the apparatus, it's really important to consider how easy is it going to be to stretch all these lines. So you've identified the FDC type and know which lines you're going to pull, and then how they're going to be pulled off the sides, off the back, etc. Hand lay small sections, etc. You should make that plan quickly, effectively, and then know that your distances, what they are versus the actual hose that you have prepped. You may have a rolled up section on the side for some, 20, 30 foot, 15 foot, whatever it is. A lot of them are different. You're on a different unit that day. You need to know that, because if you park just short of it or way too close, it's really going to mess up the water flow through it. If there are any obstructions to the stretch, or if you're going to cause an obstruction to units or operations, you need to consider that when placing the apparatus. If you've thought through all that and you position appropriately, lines should be stretched fairly easily. Here is a simple check sheet used to evaluate an FDC operation. Number 1, identify the location of the FDC, size, and type. Must be done before you can make the proper stretch. You need to identify the distance from the engine, and then of course stage an appropriate location to make for an easy stretch to both the FDC and the hydrant. Identify what the FDC supplies. They're supposed to be labeled, as you know, sprinkler, standpipe, both. And then if it's only a portion of the building, it should say a zone, a wing, a floor, or something like that. That information needs to be communicated to the incident commander. And if you're hooking up to the wrong section, that's not actually doesn't have open heads or whatever, or the standpipe doesn't go to where the firefighters are, it's not going to do you any good. So that information must be clarified prior to taking all the time to stretch lines and pump a system. You need to stretch the appropriate lines to the FDC and in a timely manner. If you do all those things, you have successfully completed this portion of the FDC operation. Here's an example of a FDC connection with Storks 5-inch line and a hydrant on the same side of the road. That's going to require, if we have a short enough section, it'll require a simultaneous operation. Whereas if we didn't have a little short section, both the firefighter and the officer would both be pulling off the hose bed, in which one would have to wait on the other. The firefighter's going towards the hydrant connection, driver's helping with that short load while the officer is stretching the hydrant. When we get to the hydrant, the cap will need to be removed with a NOx connection. The FTC needs to be inspected, and the connection will be made, and a tight connection will be confirmed before walking away. Always turn it backwards a little bit to make sure both of the ears locked. And then we'll move on to making the connections to the engine. We aren't actually going to flow water, so we don't set off any fire alarms, but we will get all the connections made. Driver's assisting at this point with a little extra hose that needs to be pulled to make some connections. We have a discharge on the officer side and intakes on both the officer and the firefighter side or driver's side. So got to make sure that the discharge goes to the driver's side. And I understand when we're making multiple Storks connections, sometimes it happens we'll connect the intake to the discharge to the intake. They're both about the same height, and it can get confusing if we don't practice it very often. So one's in, one's out. Get those right. We've got our connections made. We should be able to flow water at this point, and we are just under 2 minutes, so that should do it. This is an example of an FDC connection with a simulated Siamese and a hydrant on the same side. Now that we're pulling a Siamese, that means we're going to be, for our load, it's going to be a cross load that we can pull, which can easily be pulled off of either side. The tailboard is about even with the hydrant. If the tailboard were further back, it would be a little more difficult pull, or if we were pulling from the tailboard towards the FDC, it'd be a little bit more difficult pull because you're having to pull backwards and then go forward, in which it's going to bind and it slows the operation down. So we've got 2.5s being stretched simultaneously because they are flat loaded. They grab the 2 males on top and simply walked over. You don't have to shoulder load anything, flake anything off, just walk, make the connections. The driver who's staying back is identifying where the hose comes out. It's a 100-foot section each. So if the couplings go too far out, then he's going to have to stretch out and burn about another 40 foot to make his connections on the end. And he could do that even at this point. This stretch seemed to be like right at 50 feet. So the connections connected just perfectly. And so we've got 2 50-foot sections that are just sitting there. The hydrant is being connected to effectively as well, flushed. And then that'll be that connection will be made. We're going to have to grab a threaded connection for the Storks to adapt on there. They're trying to instill a hydrant valve in line. And so we had to grab a connection, go back over and make that connection up. And the hydrant valve is made to increase pressure for the anticipated friction loss on typically long stretches and primarily high flow situations. They make these connections and they're ready to flow water. Of course, the driver could have flowed water already before this connection's made. An FDC and hydrant are typically going to be fairly close to where a fire apparatus can park. Therefore, there's not a lot of distance that would lead to increased friction loss. Obviously, high flow is the biggest indicator, but if you're only pumping through one section of hose, the friction loss is pretty minimal. I did a couple calculations on that scenario going through 100 foot of hose, and even if we are at the rated pump capacity for our engines, we're not going to need a relay pumper. So don't worry about putting a hydrant valve or a relay pumper in between the two unless you really have a long distance and you anticipate the potential for a high flow as well. You may consider it at that point, but most often you're simply going to connect your engine to the pumper in the FDC and pump it. The next section, we'll talk about pumping the FDC. Thank you.